So for our next speaker, we have Rojan Rijal. He's a security researcher at Tinder Security Labs. He's got 7 years of experience identifying vulnerabilities in open source, SaaS, and cloud environments. Rojan has previously presented his research at conferences like B-Sides SF, the Recon Village, DEF CON 30, and in more places. Today we'll be going over common vulnerabilities in GCP Firebase with some sample case studies affecting small and large organizations. So please give a warm welcome for Rojan.
Thank you. All right, thank you everyone. So my name is Rojan, part of Tinder Security Labs. Today, I'm going to talk about identifying and securing Firebase vulnerabilities at scale. It is a 25-minute talk, so we're not going to go fully into details. It's more of a high level, looking at some API calls that you can use to create monitoring and whatnot, and also some of our at-scale research with that. The first thing is Firebase is big. There is a lot of features on it. For this specific talk, we only looked at 3 features, so you'll only be seeing mention of those 3. First one being Firebase Auth, which if we kind of create a comparison with AWS, it's similar to AWS Cognito. It has various social provider logins, Google, Facebook, all of that sorts. But then you also have other features within Firebase like Firestore, which they're NoSQL document database. Now, if we go back and compare that with AWS again, that's similar to DynamoDB there. And then finally, Firebase Storage, which is also similar if we go back to AWS to S3 buckets. GCP has its own own storage functionality. Firebase also has same functionality attached to it, but it also carries over Firebase Auth. So the reason we looked at these 3 features, starting with Auth, is because if we can find something with Auth, a configuration issue or whatnot, it can then impact Firebase Storage or Firestore there as well when you go and look for vulnerabilities or configuration issues there. For our research itself, we had kind of broke it down to 3 different paths of trying to find out vulnerabilities in configurations. The first one was manually testing, creating our own vulnerable cases, kind of a sandbox environment, mainly to get an idea of how Firebase operates. If we're going to hit an API and detect if it's going to be vulnerable or if it's going to return some kind of metadata there, how do we identify if it's a vulnerability or something like a false positive? That's where the manual testing came. We created some vulnerable examples, targeted specific organizations that we knew used Firebase, so we could take it to kind of like a real life scenario and then go from there for example cases. And then our second step was to look through source graph, which basically indexes a lot of GitHub repos, especially popular or most common ones or ones that have a lot of activities on. From there, we're pulling about 15 to 20,000 repos, looking through them to find Firebase API keys. We'll see a couple of stats on those at the end of the presentation as well of what we found with those. And then finally, we explored with Common Crawl, which basically scans a lot of websites by following their robots.txt. It then contains and stores their HTML responses and requests. So our goal was to see if we can find something there with like Firebase API keys, use that to get an idea of how many companies could be impacted, what does it look like when we look at in the World Wide Web in a sense. Credit-wise, I do want to give a shout out to a talk by Andres Riancho in Black Hat a few years back. He did the same approach with AWS Cognito. That kind of also influenced this, is seeing the level of research there with AWS Cognito, we wanted to see how it would look like with Firebase. And that's where all of this came in. To start with, the first one that we're going to look at is Firebase Auth, which again, as I mentioned, has a lot of different login providers to it. You have your email and password, you have your social providers, which would be things like Google, Twitter, and Facebook. But then also it has similar, as I mentioned before, similar to AWS Cognito. And one of the key features on there that also parallels to AWS is being able to log in anonymously. Now, if you look at Incognito, if you are able to do that, you usually can pull IAM credentials, which can then be utilized to potentially gain access to some form of AWS resources for that org. But in GCP or in Firebase, having the anonymous user can then also give you the access token for just that anonymous user, which we can further use for any kind of login activities and then try to get access to Firestore. If we take an example request with just how auth works with Firebase, is if you use the Identity Toolkit API, it will take in a username and a password, and you can also pass in a Boolean return secure token. If you mark it as true, it will return the access token for that user. But if the anonymous feature is enabled on this account, you can then also send a request without email and password, which will then return the access token just for the anonymous user. which we then use later on for any kind of like Firestore vulnerabilities. Moving on, just carrying it over to Firestore, it is basically document DB, as I said, has REST API, and that's where the authentication things come in mind, is you can basically send a regular request to the Firestore API with your project name, which in this case is test111cde14, and then the collection name, which in this case is users. If it is vulnerable, you'll be able to see data. If not, you won't be able to. So if we deep dive further, a sample vulnerable rule that is pretty common in a lot of Firestore cases where it's vulnerable would be something like this, where it basically says match any document or collections and give it read-write access if by setting the if true. Now this is also the default configuration there if you deploy it on development environment. Google has development and production environment that you can set. If you set development, by default this configuration will be used. Google has added a security rule where after 30 days your production, it will just automatically switch to production. So if companies do misconfigure it, they will be vulnerable for 30 days and then it will go to production, but they can go and revert that fixes. The other really common rule that we have seen is setting specific rules per collections. So if we look at example of this, the first rule says if a user is authenticated, then only let them see and write to the user's collection. But if they are not, then do not give them access. But if we go to the second one, it says for the organization's collection, they should be able to read-write access regardless of that. And this is actually pretty common from what we have seen. It is hard to detect this when you're doing black box because you'll usually see access denied most of the time unless you find the right collection that's vulnerable to it. But there are some ways to automate those as well by just brute forcing them. Now if we just look at the request and response of if you want to detect it at scale or just API wise and kind of get an idea of like, okay, when is this vulnerable? The first one to look at is by passing just a non-existing collection. So if you hit the Firestore API with a collection that you know does not exist on that database or in Firestore database in general for that organization, and if it returns an empty structure, that basically means that there's a rule that says any document should be accessible to any users regardless of their authentication. So even if they are not authenticated, give them access to the database. In another situation like the other rule that we saw, you'll see things like the user's collection will return access denied. Say you are missing permissions, you won't be able to do much activities there. But then when you hit the organization's collection, so if you brute force and find the right collection, you'll be able to get access to the database. But there's also a catch with that. If you looked at the previous rule, when we go back, you'll see that it has request.auth is not equal to null. So it's not checking if the user has certain permissions. All it is checking is if the user is authenticated. And if the organization now has sign up or anonymous sign up enabled, you can basically send an anonymous login request, which will then give you the access token. You can then use the access token further to exchange it and get the user's collection there as well. And this was also really common in a lot of test cases that we saw where they were using settings where if you were able to just pass in an anonymous user's token, you were able to access the entire database there as well. Similar settings will exist with Firebase storage as well, which is basically S3 buckets. You can set allow read. You will see again it has the if request.auth not equals null. If it's not null, let the user access it. In most unauth cases, you'll basically be able to list all the objects and then go through each object and get access to their specific contents there. Hitting it is as simple as just hitting Firebase Storage Google API. You do have to pass in the project name .appspot.com and then list all the objects. From there, you can then access all the objects if it's vulnerable. In case where there's or authenticated access will give you access denied, but if it's vulnerable, it will give you the content of that bucket. Now going back to request auth, same issue. If they were using request auth is not equals to null, you can again exchange the access token and then get access to the collection of the bucket. But now we wanted to automate this. So we have an idea that this is how it works. These are the responses. How do we automate? How do we break it apart and start scanning at scale with it? So the first step we used is by breaking it down into 3 steps of the script process. One is identifying the API type. If you have used Google API before, you will know that it follows the same API design regex-wise, but not everything is using Firebase. It could be a Google Maps API key, and we don't want to brute force and scan with that if it's not going to yield any result. That's where we use Identity Toolkit as a way to kind of design okay, if it's using Identity Toolkit, there's a chance it's using more of Firebase, so we can go and explore further with that. Next was scanning Firestore with 3 different checks. First check, can we access it unauthenticated? Second, if it gives us authentication issue, can we access that with the anonymous login if that's enabled? And the third case was just brute forcing with common collection names like users, profile, user account, attachments, all of that. And then finally, looking through Firebase storage, which will then allow us to view any kind of bucket instances. And same rule applies there. If it is on-auth, we'll be able to list it. If not, try using the anonymous login, which at that point we'll potentially be able to still access documents there. The first part of the identify API type, if we break it down further, we use identity toolkit because it also has a benefit of a case. Let's say if we have an API key, but we do not know the project name, which we need for Firestore or Firebase storage, we can use identity toolkit to dump all authorized domains for that Firebase project, which will include the app spot and web app links for it, which then you can use as a way to pass into Firestore API calls. This will also allow you to know that, okay, this is using Firebase auth, we can test the anonymous signup there. Next, we'll just test a regular anonymous signup, pull the access token. If it gives us admin only operation error, which usually can happen, which basically means it is disabled and it will allow email and password. In that case, we can still try email and password signup. But anonymous is the easiest way to go if it's enabled there. And then from there, we pull the access tokens, use it later on in Firestore. The first check again is with the unauthenticated access. So now we're going to pass in the project name we pull from identity toolkit and then later on reference it on the API call to say, let's hit this non-existing document. If it returns a 200 with empty result, we know it is going to be vulnerable. Versus if it returns something like a missing or insufficient permissions, now we need to explore further because there could be 2 cases where all documents may require authentication or some may require brute force and we just need to pass in different collection names and see what happens. Then finally, for authenticated access with Firestore, we can basically pass in the access tokens for the anonymous user that we pulled, utilize that to see if anon login allows us to access document. Some cases it may not if they're checking the user ID when they're accessing the Firestore database there. Similar process with storage. We can hit the Firebase storage, see what happens. If it's vulnerable, it will list all the files. If not, it will go into the permission denied and then we can rerun our checks again to make sure we can try with the anon login and see what happens there. Finally, if we script it in the end, it will look something like this where you'll pass in a Google API key. It will give you a full stats of if this Firebase project is vulnerable or not. And from there, you can analyze further if what kind of data it will have. When we did that, we started scanning the web as I said before. So if we move into stats-wise, we carried all of this over, ran it with source graph. We pulled about 15,000 Google API keys with that, out of which there was 4,000 unique. So it doesn't necessarily meant that there were some duplications, mainly because these APIs are like forked repos and all of those. So we got some duplicates there, got 4,000 API keys with it, out of which 1,700 had identity toolkit. So it allowed us like, okay, these guaranteed run Firebase. Now when we go further and break it down, we found about 249 of them to have anonymous signup enabled. Later on, exploring further, we found about 35 of them to have their database publicly accessible, regardless of authentication type. And then if we go to storage buckets wise, there's about 20 of them that were vulnerable to that as well. But now if we go back to the anonymous signup, since we have about 249 that had anonymous signup enabled, some of them were giving access denied on Firestore database and Firebase, or Firebase storage. But if we go further down, we'll see we were able to access 10 Firestore instances that had authentication requirement, but we have anonymous login, so we can just use that to actually dump the content. And then finally, we found about 5 Firebase storage vulnerables with the source graph case. Now if we go in the end to the common crawl portion where we scanned a lot more, we actually only pulled 1,000 Firebase API keys. Now the reason the number is smaller than 15,000 API keys is we changed our scanning to only look for Firebase cases. So the way we'll approach that is let's look for regex in common crawl where it will have a Google API key and see if there's mention of Firebase client or whether it's using any kind of Firebase client JS. If it is, we'll move further in scanning it. We identified about 692 of them to have identity toolkit enabled, and this was actual companies and organizations and all, out of which 80 of them had anonymous signup enabled. If we further break it down, 55 of them had their database publicly accessible to the world, and then 15 of them had their storage buckets publicly accessible as well. Now, if we look through anonymous side, we're able to access 10 database that require login, but by using anonymous signup, where 80 of them had it enabled, we're able to access 10 of their databases there. And then 10 also, we're able to access their storage also with that. Now, if we break down the categories without mentioning the company names that were vulnerable to it, a couple of examples of organizations that were vulnerable we saw is early stage startups. So anyone that's starting their new business or starting new products, they are likely to use things like Firebase or AWS Lambda or AWS like serverless models and misconfigure those instances. Same thing with Firebase, where they had used development environment, but users had started to sign up, so some of those were vulnerable in those cases. In other cases, we also noticed a lot of new AI companies that are slowly adding conversational APIs or using OpenAI's product were also vulnerable because they were building first and then securing later kind of plan with those. So we were able to access a lot of OpenAI API keys with those, which we did report to OpenAI, and they were able to revoke and work with the companies to make sure those were secured as well. Another really interesting case that we found is a lot of demo applications which we expect to have database public. So for example, if you go on GitHub and you find Angular database or Angular Firebase kind of clients, they'll usually have a demo app to show how that whole project works. The issue was with these projects, the Firestore database were publicly accessible. And users were actually testing these demo applications to see how it works and actually putting their real PII, like their email address, their phone number in these applications. So there were some cases like those as well, quite a bit of those, really interesting case as well. But that said, this is pretty much like what I wanted to talk about in general. There are cases you can add for security-wise. I would highly recommend not using the request.auth kind of thing because it is only recommending users to add authentication. But if you have anonymous authentication, it defeats the purpose there. Also, super common for new companies to misconfigure it. So you'll probably see a company vulnerable for 30 days and then be secure later on. Pretty standard if they use the development instance. But with that, if you want to follow us, I'll highly recommend following TinderEng. We post other blogs with GitHub Actions and all of the other research that we do, so you'll be able to keep up to date with that. And I'll open it up to questions now. Yes.
Are any of those automated POCs going to be available that on the screen there?
We are trying to get that open source, so we'll see if we'll be able to release the whole script with that.
And if I follow you, can I find like repositories or something for this?
Yeah, the question was if you followed, if you'll be able to find repos. If we make it open source, we will publish it both on TinderEng and my personal account. If you also go, it's not mentioned here, if you go to TinderSec, that's our organization GitHub repo. So that's where all of our tools will live whenever we open source any kind of tools there. Awesome. Any other questions? We're good. Yep. Thank you, everyone.